Let's take a look at base speed down. So the principle of base speed down that we have to remember is that it has everything to do with the armature current and only the armature current. When we affect armature current, we can affect base speed. Now base speed means the maximum speed we can get with the existing field in the shunt. In other words, if I do not change the shunt field, again, your shunt field is this guy over here. If I do not change that, in other words, if I do not allow more or less current to go through that shunt field, I will only get a maximum speed over here on the armature. And I can adjust from base speed, which means full load speed, and down on that armature by affecting how much armature current flows through the armature. Now you will notice up here I have a little rheostat. So what we're going to do is we're going to adjust that, and all it really is a variable type resistor type thing, and we're going to make sure that we either cause more resistance, which will lessen our current, or we will lessen our resistance, which will allow more current to flow. And then we're going to see how that affects our base speed down. So if I was to increase my rheostat, or the resistance in the armature, as soon as I do that, the next thing you have to ask yourself is what happens then to current. Okay, so if I increase resistance, my current, of course, in the armature, which is what we're talking about here, will go down. Okay, so if my current in the armature goes down, then what happens to torque? Well, it stands to reason with less armature current, we're going to have less torque. With less torque, what does that mean for speed? Well, clearly that means we're going to reduce our speed. Our speed will go down and to that new equilibrium to make sure that we're still driving the load, but at that new equilibrium. So that's really your base speed down, and again, that is affecting, and that's only by affecting armature current. Alright, we haven't touched our field current in any way, shape, or form. That's only armature current that we've dealt with. Now if we would like to affect our base speed, and again, base speed is the speed we will see when we are at full load with regular shunt current and regular and full load armature current. Remember, your shunt field is going to draw the same amount of current no matter what the load is. It's simply a coil. That coil is going to draw X amount of current, whatever that is, and it's usually approximately in that realm of 5% of whatever your armature current is. So we had just discussed base speed down, which again is your full load speed, which is nameplate speed, and lower. Now if I actually want to take that nameplate speed and I want to go a little bit faster than what the nameplate actually says, I can do that. The important part to remember is that the only way to do that is to either increase my armature voltage, and that's a whole nother discussion. Increasing armature voltage will increase armature current, and an increase in armature current means more torque, means more speed. But as far as regular, without changing our voltage across our shunt field or our armature field, if all we want to do is get base speed up, all we have to do is affect the amount of current flowing in our shunt field. And we can actually do that by allowing more current to flow or less current to flow. So by placing a rheostat in the field winding, and that's what you see right here, we can actually affect how much current flows through that shunt winding. So let's see what happens when we adjust that. So if I was to say to you, we're going to increase the amount of resistance in the field. So if I take a look at my resistance in the field and I want to increase that. If I increase that, the next question you ask yourself is, what does that do to the amount of current flowing in the shunt field? Well, by this point you're probably going to be able to bang these answers off, and you're going to say the field current is going to go down. If the field current goes down, now we go over to the armature and ask ourselves a few questions over there. If I have less current flowing in the field, I know that my north and south pole, so my magnetic field in the shunt winding, is going to be smaller. In other words, I have that north and south field is going to be in the arm, and that's in the arm, or in the field rather, is going to be smaller. Okay, I'm going to have less lines of force going from my main north pole to my main south pole in the shunt field. The result of that is that my armature that's spinning right now will actually cut less lines of force. Alright, so my armature winding, we'll just try and write this all down. So my armature winding will cut less lines. Now, if it's cutting less lines of force, what does that mean for counter EMF? Well, my counter EMF would go down, which allows my current in the armature, so we're going to go I arm, my current in the armature will then go up. If my current in the armature goes up, my torque goes up. If my torque goes up, my speed goes up. So what we have done is we've taken a motor from nameplate speed. So for example, if the speed says 3450 is our full load speed on the nameplate, we can actually go above that by increasing the resistance in the field. Hopefully that'll help you out a little bit, and you can play this back as many times as you want. Clearly that's the nice thing about these little scribble casts. And if you ever have